So this is a small project which I made using Pyqt library in Python. And this is a simple GUI which can be used to visualize any data and then train different possible ML algorithms on that data. Right now I have this list of algorithms coded within it. I am in the process of adding a few more. So first of all, we will just have to click on browse and upload data in CSV format. So let me go with the Titanic dataset. So once the data is uploaded, this is the list of all the columns in the data. This is the whole data itself. Here we have the option of selecting which is the target data for us. Like in this case, the target is survived, whether the passenger has survived or not, that is our target. So we just select it, we click on target. So the target is set over here. This is the list of all the categorical columns within our data set. So in any ML algorithm, we need to convert all the categorical data set to a numerical data, so to a integer or float, whatever it is. So we have the option of converting these categorical columns to integer. Here we have all the columns which have some empty values within it. For example, the age. So let's see. Here's the age column. As we scroll down, we have a NaN over here. Similarly, if we go to cabin, so let's see cabin has NaN over here. Similarly for embarked, where is it? Here's embarked NaN. So here we have the option of filling these empty columns either with the mean values or with the word unknown. So that is a limitation for now. We can also add a field over here to add custom values. So for now, let me just fill all the empty values within age with the mean value, and with the cabin with unknown and embarked with unknown. So it is filled over here, you can see. We can convert these categorical columns to int, but before that let me drop a few columns which I don't think are required in during the training of our algorithm. So I can drop passenger ID, that is unique for everyone. I can drop the name. I can drop maybe the, let me drop fare, let me drop cabin as well. So, and let me convert the remaining categorical columns, and that is done. Okay, also we can scale all the values using a standard scaler that will help our algorithm to perform better in some cases. So let me click on that. So you see all the values are now scaled. Okay, here are a few plots through which we can visualize the data. Suppose I want to visualize the plot of maybe age, the plot of sex versus age. So this is how it looks. Not very useful for now, but I'm just trying to show a feature of this GUI. Similarly, we can draw line plots. Here is a line plot, again not very useful. And we can add columns here for which we want to see the histograms. So I've added P class, sex and age. Let me click on show. So here I have 3 histograms. This is the histogram for P class, this is the histogram for sex, this is the histogram for age, right? And also we can see heat maps. Heat maps are used to see correlation between different columns, and with the target column, the correlation between the target column with all other columns within our data set. Here we can see the heat map as well. And so let me not try to train it. I can use any of these. Let me try with logistic regression for now. I click on train, the window opens up. So here I can set the test data size, the data which is keeping out as a validation data set basically. So I'm keeping it as 0.1. So 10% of the whole data is kept aside as a validation data set. Click on set. Here is the shape of the train size and the test data size. These are different parameters within the logistic regression function which we can set. Let me keep all of these to default for now. I click on train and the data gets trained, and this is the classification report. We see we achieve an accuracy of 84%, and these are the mean absolute error, mean square error, and the root mean square error. You can also click on confusion matrix to see how data performed on these specific classes. So we can see when the actual class was 1, in 33 times it was predicted correctly, but 6 times it was predicted incorrectly, and when the actual class was 0, 8 times it was predicted incorrectly and 43 times it was correct. So that is the confusion matrix, and we can download this data, we can save this data. Let me do that. Let me save this data. I'm saving it as titanic.pkl. Okay, so the data is saved. Let me close it. So I can also browse a pre-trained model. So we just saved the data. Let me open that. Titanic pkl, go. Okay, so here is the model which we saved, and we see that it is a logistic regression model. The parameters are these are the columns on which we are going to test, and these are the steps which were performed while training the model. So first we fill the empty values of each column with mean, we filled the cabin with unknown, embarked with unknown, then we dropped passenger id, we dropped name, we dropped fare, cabin, we converted these columns using label encoder, then we scaled the data using a standard scaler. So now let me test it over here. So this is the accuracy 79%, and absolute error, square error, we can see everything, and again we can see the confusion matrix also. So this is how this GUI can be used. I can also use it to train let me train a multi-layer perceptron, basically a neural network. So again I can set the data size, the train size and the test size. I can set the hidden layers. Let me set it to 3,3. I can set the activation functions within these hidden layer. I'll set it to logistic. I can set the solver. I'll keep it as Adam. I can set the alpha value, the learning rate, the maximum iteration. Let me keep it as default. So when I train it, it gets trained, and I'll click on train. It gets trained. You can see with every iteration, the loss came down to 0.68, and then it did not change. That is what it says. And we get an accuracy of 56%. So let me try and change it. Let me change the learning rate 0.01 and the maximum iteration to 800 maybe. Let's set and train. So this time again the loss gets stuck at 0.659, and it did not improve after that, therefore it was terminated. And this is the accuracy, this is the classification report. So we can make whatever changes we want to. I can convert this to ReLU, then try to train it. Okay, there's an improvement in the accuracy. We have accuracy of 80% now. Okay, we can see the confusion matrix. This is how it looks. So we can just quickly make changes within our GUI and train the model, and when we are satisfied with it, we can just download it and then use it whenever we want to, wherever we want to. So that is its utility. There are many possible upgradation which can be done for this GUI, and I'm in the process of doing that. So if you want to find the code for this whole GUI, that is there in the description. There's a GitHub link in the description. You can go over there, you can fork it, you can play around with it, and I'll be updating it frequently from now.